Hello, in this video we're going to talk a little bit about how to find a binomial probability. Now, a binomial probability has different characteristics, of which happen to be that you would have that there are n independent trials, and then you would have that there's a probability of success, and then you'd have that there's a number of successes. Now, when we talk about binomial probabilities, one thing that we have to consider is that the probability of success is very subjective, but you do have that it's fixed. So this probability of success will never change. So we'll just add in the comment that it's going to be a fixed probability. Now, there is a formula that does determine that probability of a binomial. Now, the formula is given by the following. We have a probability of a random variable x is equal to combination n comma x multiplied by p raised to the x. Maybe I should change the multiply symbol because that might get confusing. So we'll just say multiply. And then we have 1 minus p raised to the n minus x. Now, this is actually a bit complicated if we think about it in terms of like, how do we use this, this formula? So the extra thing that I'm going to add in before I kind of explain a bit more is that this is for what we call an exact probability. Okay, so in any case, if we were going to look at this, this is only for an exact probability. So let's think about this. Like, why are we multiplying by a combination? Well, let's say that, we're going to roll a die. Well, I know that the probability that it lands on my selection is 1 out of 6. Now, let's say that it's rolled 5 times. And let's say that we just want our die to land on 2 3 times. Well, what this means is that we would have to basically figure out that, well, we have that there has to be 3 successes and 2 failures. So we have success, success, failure, and failure. But if we think about it even more, we have that this is actually going to be where we could say, okay, well, we have 3 successes, so that's going to be 1 out of 6 raised to the 3rd power. But then we have that the probability, or we have 2 failures, so that means that we have 5 out of 6, and that's raised to the 2nd power. But here's where it gets a little tricky, because notice that we had that there was 3 failures. Or no, I'm sorry, 3 successes. And then we had 2 failures. So what that means is that it's kind of like we're ordering the number of successes, because another possibility that you could have is, for instance, we could have the first is a failure followed by success, success, followed by a failure, followed by a success. So this is another possibility, but who has time for that? So we'll just go ahead and say, well, since I know that there's 5 different objects, then that means that there's going to be 5 to select from. So that's the 5. And then we have, how many are we selecting? 3. So that's going to be 5 choose 3. Now, you do not have to do it like this all the time, because in any case, we have a formula and we don't have to technically outline it. So if we plug this into our calculator, well, if we do 5 choose 3, remember that that's going to be 5 factorial divided by 3 factorial and 2 factorial. And this is going to be 1 out of 6 raised to the third times 5 out of 6 squared. Now, we can do this in the calculator where we just go ahead and go to where we find that we're going to do 5, and then we're going to do combination, and then we're going to do 3, but we're going to multiply this by 1 out of 6. And then we're just going to raise that to the third power. And we're going to multiply this by 5 out of 6. And then we're just going to raise that to the second power. Now let's hit enter. And accordingly, that's going to be 0322. So that's going to give me 0.0322. And that's the solution. Now, that actually looks quite difficult if we think about it, and there is a way to do the probability in the calculator. So we know that the probability of x equals to little x is equal to that complicated formula, but there's another way that we can do where we use our calculator to use Binomial Cdf, and our parameters are n, p, and x. So what that means is that the solution to the previous problem or the example is the probability that x is equal to 3 is equal to binomial Cdf, and then we're just going to input our different parameters. So it was rolled 5 times, the probability of success was 1/6, and then the successes was 3. So that's just going to be that. Now, how do I do that? Well, I just need to go to my calculator and go to second vars, and then go to Binomial Cdf. And we're just going to select 5, go to 1 out of 6, and then we're going to select 3, and then we'll just hit enter. And that's the exact same thing. Okay. Well, what we can do next is a classical problem. So let's say that there's a family that has 6 children. And then suppose that we want to find the probability the family has, let's say, 4 boys and 2 girls. Okay, well, this question says that we can just go ahead and find that we have that the number n is going to be 6, the number x is going to be equal to 4, and our p is going to be 0.5. So we have that that's going to be the probability that x is equal to 4 is equal to combination 6 choose 4 multiplied by 1/2 raised to the 4th power, and that's going to be 1/2, and then that's raised to the 2nd power. Now if we do this, then that's just going to give us that we'll have to find 6 choose 4 multiplied by 1/2 to the 4th, and so on. Okay, but let's go ahead and use our calculator, where we go ahead and we just say that, well, let's go ahead and write this out actually first. So to find an exact probability, we're saying that we can use Binomial Cdf, and that's just going to be 6, 1/2, 4. Okay, so if we do that in the calculator, and let me just borrow this. So the family has 6 children, and the probability that a child is born, let's say that that's just going to be 1/2. And they're going to have 4 children that are boys. Okay, so we find out that that's going to be 0.2344. So that's just going to be 0.2344. And then that's just going to be it. Now, one thing that we can look at is for when we look at the at most scenario. So an at most probability is given by the probability that x is less than or equal to our little x. Now what this means is that basically that you're just calculating from the smallest. So for example, if I was going to roll a die and I wanted to know what is the probability that I have at most 4 of my 2s, then that would mean that I would have to do the probability that x is 0 plus the probability that x is 1 all the way down to the 4th outcome, which that's going to take quite a while. So, like, let's say that we wanted to find that probability. So we'll just say that, okay, well, if a die is rolled, let's see, I think we said 5 times. Let's just go back and make sure. Yeah, it was rolled 5 times. And the probability that it lands on my choice is going to be 1/6. And then we're saying at most 4, so that means 0, 1, 2, 3, and 4. But we don't have to do it this way because there's an easier way. Thankfully, we have x is less than or equal to 4. If I happen to accidentally write capital X, little x, it's okay. I mean, just as long as you understand that the random variable is given by x. So we're going to say that this is going to be using the Binomial Cdf function. So that's just going to be, so we have that that's going to be 5, 1/6, and we're just going to put 4. So that's going to actually shorten the computation because we don't have to go through the process of finding each of those because that's just going to take too long. So we'll just go to our calculator and we'll just select Binomial Cdf. So the CDF is for cumulative. So the number of trials is 5, the probability is 1/6, and the x value is 4. Now keep in mind that that's selecting up to 4. So we click enter, and okay, so that's a really high probability. So essentially it's almost like 100% that your choice of number comes up. So that means that this is going to be approximately 0.9999. Now that's not too bad in terms of like thinking of like the odds. So like if you wanted to make a wager, you could probably say, well, you know, I'm gonna choose that my number is gonna come up at most 4 different times. So that's really good odds. So just to clarify, the function that does this for you is the binomial Cdf, and your parameters are n, p, x. Now, one last example. Let's say that we have that we want to know that, say for example, that there's a quiz. So we have a 10-question quiz. And we have that there are 4 answer choices. Let's go ahead and just and then we have that only one of which is correct. So let's say that we want to find the probability of getting at least 6 correct. This is a classic example because usually it's asked in a statistics course to see, like, you know, if we were pure guessing on a quiz which was multiple choice, we can actually figure out like what is the probability of passing. So this is an example of finding the probability that you're gonna pass this quiz if we're just gonna do some pure guessing. Now let's go ahead and forget the whole idea of testing strategies where you can eliminate an answer choice if you use the strategy of choosing keywords that would eliminate a solution or an answer choice for that matter. So we'll just write this out, like how this looks. So we have the probability that x is, okay, so it's at least 6, so it's going to be greater than or equal to 6. But this means that we would have to find the probability that x is equal to 6, plus the probability that x is equal to 7, plus the probability that x is equal to 8, and then plus the probability that x is equal to 9. And then let me just squeeze in this, x equals to 10. Okay, now as you can see, that looks like a long computation that I need to do. So we have to think of another way to do this problem. So the easiest way that we can do this computation without having to do 5 different computations is, why don't we just use the complement? Because what we can do is just think of, well, I know that if I just take the complement from the probability that we get 5 questions correct at most, then this is actually going to give us the same thing, but just a shorter method. So we will go ahead and just say that we want to find the probability that we can get up to 5 correct. So let me just put that. But we know how to do this. This is just going to be 1 minus binomial Cdf. And then we're just putting our parameters. So in this case, the parameter is that there's 10 questions, but the probability of getting the question correct is 1 out of 4. So we have 1/4. Now, we said that we're going to calculate up to 5, so that's just going to be that the x value is 5. Okay, so let's go ahead and use our calculator to find this. So that's just going to be 1 minus the probability. Okay, so yeah, so we just need to select Binomial Cdf. So there's 10 questions in the quiz. It's 1 out of 4, and then it's up to 5. So we click enter. And okay, so there's a 0.0197 chance of passing. So we're just going to say that we round to 4 decimal places, and we get 0.0197, or about 2%. Okay, so that's actually pretty interesting, given that it's telling you that you have a really low chance of passing a quiz if you're purely guessing. So in that sense, that means that, if you look at it like this, that the probability of not passing this quiz is 98%, and that's not very good. So, clearly, like in the statistics problem, they're trying to imply that, if you do study, you would increase your chances of passing this quiz instead of just purely guessing. Okay, so that's how we do the binomial probability distribution. In the next video, there's going to be some examples of how do we make a table from scratch when dealing with binomials, and also like what do we do to find the average or the mean of a binomial distribution, and also looking at the expected value using a formula.